So here's a video about areas and volumes of similar shapes. Before you watch this video, you should watch the previous video about similar figures, which deals with the B grade questions, and now we move up to the A grade questions. Remember, similar figures means that one is just an enlargement of the other, so everything increases in the same ratio. So for example, if I took this cube and enlarged it by scale factor 5, so every length becomes 5 times bigger than it used to be, what we notice is that although the lengths have increased by 5, the areas increase by a different scale factor. The area of this side here, for example, would be 1 times 1, whereas the area of this side here would be 5 times 5. So the area has gone from 1 to 25. So the area is increased by 25, not by 5. Lengths have increased by 5, areas have increased by 25. And if we look at volume, the volume of this one was 1 times 1 times 1. The volume of this one was 5 times 5 times 5, which is 125. So although lengths have increased by 5 and areas have increased by 25, volumes have increased by 125. So when we put that into a table, we can see that the ratios relate like this. Now, hopefully what you can see is whatever length or whatever ratio has been used for the lengths, it's the square of that ratio which relates to the areas, and it's the cube of this ratio that relates to the volumes. This is just like the units for lengths, areas and volumes. If you think length might be centimetres, areas would be centimetres squared, volumes would be centimetres cubed. So whatever I do to the lengths, the square of that effect happens to the areas, and the cube of that effect happens to the volumes. So that's what I've summarised here. Whatever I times the lengths by, the areas will grow by the square of that, and the volumes will grow by the cube of that. Now this explains a lot of things that go on in business and marketing and in the everyday world, even in the size and height of human beings and sports science and PE. For example, if we had an oil tanker so that we made the new oil tanker twice as long, twice as high, twice as wide as the original one, so all the lengths have been multiplied by 2. Going back to this, that means the areas have been multiplied by 4, and the volumes have been multiplied by 2 cubed 8. So this new, bigger oil tanker, although it's twice as long, twice as wide and so on, it carries 8 times as much oil. Now it won't be 8 times as expensive to maintain, and it won't require 8 times as many crew, but it will contain 8 times as much oil. So it becomes effectively what economists call an economy of scale. The bigger it is, the greater the ratio of the oil that you can transport to the costs of doing so. For example, painting the thing only costs 4 times more than it used to, but the amount that you get for a full load of oil goes up by 8 times. So there's an example here of how this can be used in marketing as well. People in marketing will use human perception of shapes and sizes, which doesn't necessarily tie in with what the maths tells us. So, for example, suppose we wanted a king-size can of drink which holds twice as much liquid. Well, if the volume has gone up by 2, now work back this time, so the length must have gone up by the cube root of 2. Remember that volume goes up by length cubed, so length must go up by volume cube rooted. So the length has only gone up in the ratio of 1.26. And whatever happens to the length, the square of that happens to the area. So the area has gone up by 58%. So even though this can only looks like it's a quarter bigger, it's gone up by 1.26. So a 10 centimetre can, for example, would turn into a 12.5 centimetre can, 12.6 centimetre can. It contains double the volume. Now if you turn that around, this is how marketing people use it. They will say, look, if we go from this, our regular can, to this can, which is only about 4/5 of the height, people will perceive that they're probably likely to get 4/5 of the amount of drink. But actually, because the height has gone down by 4/5, the volume will go down by about 4/5 cubed, which means you're only getting half the amount of drink in this can. So marketing will say, look, this can's gone down by about 4/5. If this can costs £1, we'll be extra generous and make this appear that instead of costing 80p, 4/5 will make it cost 70p. And actually what's happening is, instead of selling one can for £1, they're selling 1/8 of a can for 70p, so they're making a much greater profit because of the way human perception works.